Right, we are trying new ways for remotely presenting. Right, so beginning with this project, digitizing food surplus data in Thailand. STFC, IoT, AI applications. So we were trying to explore where STFC, IoT, and AI applications could fit in. Why? I'll tell you in a minute about the challenge that they were facing. So before I begin, I would like to introduce you to my long list of teams. And without them, this project wouldn't have been a success. So from the UK, it was myself, Jens, who is presenting remotely after me, and Mark Pipe from STFC Hartree Center. Jens is from computing facilities, so he works on high performance computing. Christian Reynolds, he should be here, or if he's not, then he would be around somewhere. Bob was here, yeah, okay. And Anurag, he's not here, unfortunately. But from Thailand, we have Spencer, yeah, Chris and Bruce. So it was a long list of teams, and we all came together and performed this project. And this picture on your right-hand side, no, on your left-hand side is just to tease you. Yeah, because in Thailand, we were really amazed by the hospitality they showed us, and there were a few people who couldn't come to the workshop. But this is just to make sure that, you know, when we have international partners and international projects, we do take every opportunity to go there and meet with them and have a table conversation, because most of the innovative ideas happen over the table conversation, and so it happened with us as well. Now let's see. Main challenge that we were covering was mostly related to food surplus in hospitality industry and supermarkets, which unfortunately, if it is not redirected, mainly goes to the waste, okay? It mainly goes to landfill. So we started off with one single case study. We collaborated with an NGO called Scholars of Sustenance, and thanks to Spencer for making the connection. This connection was possible from University of Sheffield funding before in March, and then we applied for SFN 1.0 funding for the scoping project. So this was mostly in relation to redistribution of food from food surplus areas, and mostly what this organization, NGO, is doing is they are collecting food from 5-star hotels, restaurant, especially after the breakfast, and supermarket surplus food and directing it to the food poverty area, charities, orphanages, refugee camps. But the main big question that we were trying to answer is, how do you efficiently and effectively redistribute the food, okay? So this NGO, they were collecting food from 45 different points, and now they are doing it from 60, but at that time it was 45. They were having 4 trucks, 10 distribution points, 4 categories of food that they were collecting: bakery, fresh fruits and vegetables, cooked food, and frozen category. Right, the problem, so ideally, in the ideal case, you would understand that, you know, there is availability of data, and automatically it gets to the NGO, and they go and they collect and they distribute. But what we found out when we did our field work in Bangkok, so we had 4 teams. They all went to 4 different truck drivers, did some observation from 10 o'clock in the morning to almost like 11 o'clock in the night. So we were with them. We actually understood what were the key problems and the reality of the food being distributed, or, like, you know, how the data is being actually collected. There was again multi-stakeholders workshop where we tried and invited a lot of 5-star hotels procurement managers. So there were around 18 5-star hotel procurement managers in Bangkok, and they were our team. There was a team from the UK who went there, some STFC person, so from Hartree it was Mark Pipe, then Christian, he's back here, so he was there in workshop as well. Bob was there in workshop, and we organized the workshop with around 31 participants, and thanks to Spencer for bringing all the different people from different areas in Thailand to understand the challenge in a more in-depth way. So yeah, this was the pictures from the workshop where we went to NGO. We saw that there's a lot of food surplus being redistributed. So that's all the food coming from Tesco Lotus in Thailand, and the whole team that was ready and enthusiastic to work for food surplus, for redistributing the food surplus. So just a moment, it's loading. Okay. So yeah, as I told you, ideally they should know what is available and when, so that they can plan their journey accordingly and who needs what. So all this information is really important. Reality, when we went across and did some field work, we found that there is no visibility of data for food availability or food choice. So there is a lack of information flow. They go there, they see sometimes that there are small portion available from the hotels, and sometimes there is no food available from the hotel. Okay, manual data entry. So ideally, you would want that everything is transferred directly to the cloud, and the data is stored there. But normally, what they do is when they go there, the first manual entry is through WhatsApp. So they take the pictures and the measurement, the weight measurement, manual weight measurement there. And then the second manual entry is from WhatsApp to Excel. Okay, so that sort of inefficiency is there. 2 times manual entry. Waiting time is too long when they go to hotels. They have to wait for quite some time. And I think the longest I waited with them was around 26 minutes to get the food from the hotel, from the 4th floor. Okay. Recipients' food utilization data, that is unknown, so you redistribute the food, which is great. And on the picture, you can see here, okay. On the on the right-hand side of you, there are two pictures showing they are collecting the food from hotel freezers. Then we are stuck in quite a lot of time in traffic in the middle to reach to one place to another. And then towards the end, it's a refugee camp where people are coming and collecting the food. But we don't know how much food has been actually utilized at that point. So there is quite a lot of lack of route planning. So the way forward, we approached Jens with all the problems, and he had some magic solution of prototyping food waste data collection through MF2C, and Jens would be able to tell you more about it. So that's one of the steps that we have taken, so automating the food waste data collection. Next steps, what we really want to do is some follow-up funding for prototype development that Jens is working on, TRL level 6 or beyond, geotagging all the possible locations where the food is available, where the food is needed, mobile app application design, some market analysis to be done, how the prototype could be uptaken, and and hopefully we can achieve the impact.
Thank you very much, Sonal. Thank you, Alison. So, what Sonal just described with using WhatsApp sounds like a wonderfully silly procedure with all this stuff that you have to do. So I thought, could we do better? So, using these wonderful Internet of Things technologies and stuff, it might be possible to take the scales at a hotel and connect them to the cloud and see if we could make a better service out of that. And I should say, I'm sure we will make the slides available, so if I rattle through things rather quickly, then you can read things at your leisure afterwards. But the basic idea is to put measurements where the food is made available. So you put something on the scales, you press a button saying, I've got some rice, or I've got some meat, or frozen meat, and it will then aggregate stuff at a regional level, so you can coordinate a lorry that goes around and picks up things, and you can also aggregate things at a higher level, so you have an overall view of how much food is made available and how quickly it's being picked up, and you can produce some statistics, and you can maybe even reward people for making food available by giving them gold stars or something. So the basic architecture, if you look at the measurement bit, is to take the scales, to convert them, the data from them, into something that can be stored locally in case the internet connection is lost, and then it can be transmitted when food is available to a service in the cloud or regionally that alerts the lorry to go around and pick things up. And you can make this a bit smarter as well by optimizing the route of the lorry, because if we have enough computational capability, we can say, oh, we've got 5 or 6 things in a reasonable neighborhood, and you can calculate what is the best route for the lorry to go and pick it up. So building stuff for the Food Plus network was an interesting little challenge, and then I could reuse stuff from the MFC project that Sonal mentioned, where there's already an infrastructure for making sensor data available in the cloud. So here's what the prototype sort of looked like. Scales come with interfaces. At a basic level, you can do it with precision scales, tend to have them mostly, and also very large scales, but not your kitchen scales normally. Serial bus, just like USB, but a much older version called RS-232 that I tried to connect with a translator in the middle, and then it connected to an Arduino that's hidden under a probe. And initially I had trouble making sense of it because the voltages seemed to fly all over the place, and they were not what I expected. But I eventually figured it out, because it wasn't in the documentation for the scales. It was just, I had to actually figure things out. So it turns out it's not using the classical RS-232 voltages, it's using more modern chip level 0 to 5 volts. So that's fine. I figured that out eventually, which means I don't actually need the adapter at all. I can connect it straight into the Arduino. And once I did that using an improvised RS-232 cable, then I had success. I could communicate, I could get data, as in this picture, from the scales, and I could also send commands to it. I have a little video where I send a command every 5 seconds to change the measurement unit, which looks kind of funny, and I'm sure that would confuse somebody trying to use it. So this is what the prototype ended up looking like. I didn't have the right cable, so I just improvised with a few pieces of wires, and you can see the oscilloscope probes hanging onto bits of it to measure things. There's also a keypad, which it's just like a telephone keypad or something, but it was really meant to simulate that you press a button that says rice on it, and you press another button for frozen meat, and you press a third button. So the button press serves 2 functions. First, that it tells you what sort of food is available, and secondly, that it's an event that makes data sent to the cloud, because it says there is food available, so it's triggering an event, it's triggering processing in the cloud. Here, I cheated a bit and used a laptop to connect it to the cloud service, but in a production environment, you would probably have something slightly smarter. So I also tried to, for the keypad, which was a 4x4 set of keys, I tried to minimize the number of wires I needed by having scaling the voltages from 0 to 5 volts. So 0 volts being no heat pressed, and then with the different voltages at different rows, and I could then use the analog to digital converter to determine which key was pressed. And this works fine as long as you just put one key at a time. So building this from scratch might be interesting, but that's not what we wanted to do. We wanted to build on a platform, because that would make it much easier to develop applications, even if the platform comes with features that we don't need at the current stage. Because we wanted to do computational things as well, like blockchains or optimizing the route for the lorry or something similar. Also, prioritizing foods that is perishable. So the system needs to be a bit smarter than just blindly sending data into the cloud. So the infrastructure of the platform looks a bit similar to how we imagine the sensor sending data. There's a set of agents that communicate with each other, and there's a leader agent that can communicate stuff eventually into the cloud. And the system kind of self-organizes, which one is the leader, which ones are followers. And if the leader dies, then somebody else takes over, and inside the agent, there's loads and loads of stuff, and many a thing that we do not need at this stage. But it could still be useful because it monitors whether agents are reliable enough to do the work that we ask them to do. And if there's a computation that we ask it to do that they can't do, they will automatically offload them to the cloud. So there are actually lots of nice features in this. So that is to simplify this setup a bit, because this was all sort of loose wires and Arduino that I happen to have lying around. And it would make sense to actually simplify this with a smaller microcontroller. And one of the goals was to use as few external components as possible. So the Arduino had software to communicate RS-232, and it had the hardware bus, hardware serial port to communicate with a laptop. And we could make this a bit smarter by, and then reduce the size of the microcontroller and make it cheaper. We can look at other things as well, like blockchains. You could imagine that an anonymized published piece of food would appear as a blockchain entry, so you can see that somebody has made food available, and overall a third party could get a view of how much food was made available and how well the system is working without revealing the identity of the individual restaurant or cafe. The calculations, the optimization of the lorry I mentioned. So there are lots of interesting things that one could build on to make this even better. But I think already in the present state, with a button press, you put things on a scale, you press a button, and that's a huge improvement on the WhatsApp and stuff, because the Excel part is all happening automatically. So it can be done. It was quite interesting to put it together. The deployment of the cloud infrastructure is quite modern, using containers and using clouds and OpenStack and stuff. So all of this is also very interesting. It's sometimes challenging to reuse stuff that comes out of a research project, but then that would also be the next step, to take the bits that we actually need. And with that, thank you very much.
Thanks, Jens.